The scrape surface seems to go on forever. This is the GSE 500A thread grinding machine with a sliding surface that is an exceptional 12 meters long. Despite this length, the GSE 500A achieves axis straightness to the micron level. MITSUI SEIKI Kogyo Corporation Limited started out producing measuring instruments such as gauge blocks and now produces various types of mother machines, meaning precise machines that facilitate making other precise machines. This includes the world-leading jig borer, the pinnacle of metal cutting machines. How are these mother machines made? Let us introduce our technology and techniques. Scraping is the process of manual fine machining of the surface of machine components by using a chisel-like tool. The amount that can be removed at one time by scraping is about 1 to 3 micrometers. As we know exactly how much material needs to be removed, we can precisely create any shape. Unlike conventional machining, the major benefit of the hand scraping process is critical accuracy corrections. Simply saying, the reason for performing scraping is to create components that are better than the assembly that made it. The precision of a part cannot exceed the precision of the machine that processes it. Only by applying the human skill of hand scraping is it possible to create something that exceeds the precision of the processing machine. There are 3 main purposes for scraping: achieving straightness, squareness, and flatness of sliding surfaces with high accuracy. Creating a surface that takes deformation into consideration to accommodate displacement due to the weight of the parts placed on it. Creating surfaces that allow parts to be joined together without deformation when these are joined together. When an object, such as a table, saddle, or column, moves on a linear axis, there are slight differences in posture in the up-down, left-right, and front-back directions. If a sliding object, which should normally move in a straight line, moves incorrectly, it cannot be called a high-precision machine. The accuracy of an object moved on a linear axis is determined by the accuracy of the sliding surface. The sliding surfaces of all the machine tools produced by us are hand-scraped to minimize posture differences. If the sliding surface is perfectly straight and a heavy object is moving on top of that sliding surface, the straight surface will then be slightly deformed. By hand scraping a sliding surface with a slight difference in height at the center compared to the ends, the object can then move with the desired straightness. A desired curve on the sliding surface is created by scraping, and the results are checked by using an autocollimator or laser measuring device. A mirror placed on the scraped surface is moved at regular intervals, and any slight angular deviation of the mirror is measured with the autocollimator or laser measuring device. All scraped surface straightness deviations are recorded by plotting the angle at each measurement location. Scraping is repeated until the desired curve is achieved. This process is a formidable task, and even more so with longer sliding surfaces. When assembling a machine, if unbalanced parts are mounted, the parts which should be perfectly square to each other become slightly out of alignment. By taking this deformation into account in advance, mating surfaces are hand-scraped to obtain proper squareness when assembled. Even if the mating surfaces of 2 objects are not flat, these can be forcibly joined by using bolts, etc. However, since there is a residual force that tries to return these parts to their original state, 2 objects become distorted over time. Hand scraping surfaces flat prior to assembly will eliminate the mating stress and permit stable precision over time. This allows our products to maintain high accuracy over long periods of time. This is a brief comparison between the generally used method and our standard practice to produce machine tool slideways. The common method is to heat treat the specific slideway surfaces of a casting to increase hardness, and then process it with a large slideway grinder to create a sliding surface. In this process, the accuracy of the sliding surface depends entirely on the accuracy of the slideway grinder. Additionally, durability of the ground cast iron is limited because the hardness of the guide surface is low. On the other hand, we scrape the cast iron mounting surface of the casting to the desired shape and accuracy first. We then install precision hardened and ground steel guide rails to this accurate surface. For box-type slideways, these are always mounted from the backside, away from the sliding components. In addition to the initial accuracy, box-type slideways has sufficient hardness, so it is resistant to wear and can maintain the accuracy over a long period of time. Our ongoing policy is to build up the machine's total precision from the basics. Even with this approach, when the machine is finally assembled and its accuracy checked, there may be slight errors. We will not compromise on even the smallest deviation. The machine units are disassembled, and the sliding surfaces are re-scraped to make fine adjustments to achieve the final 1 micrometer accuracy. Hand scraping is an old technique that has been around since the dawn of machine tools. Even with today's highly developed technology, there is nothing which can surpass it for ultimate mechanical geometry. We will continue to cherish our scraping technique and skill, as it is indispensable in creating mother machines of the highest precision.